Hey guys, it's been a while. I got a few questions about the right hand rule, probably because it's kind of a weird idea. The idea that you can take your right hand and somehow it represents magnetic field and magnetic force and current, and how they all interact is strange, but it works. And here's why. So the key to this is that current, the magnetic field, and the magnetic force acting on the current are all going to be perpendicular to each other. This means they're going to be at right angles to each other. And it just so happens that with your right hand, you have three things that are all at right angles to each other. Your thumb represents current. So current is your thumb. The magnetic field is going to be your fingers. So ways that people usually use to help memorize these things. Your thumb, so current is the thing that's actually moving. Well, your thumb is what you use like when you're hitchhiking. So when you're trying to get somewhere, you're trying to move, you use your thumb. So your thumb is the thing that's moving. You feel with your fingers. Feel, field. So that's how they memorize that. And then your palm represents magnetic force. And this is usually memorized as in you apply a force to someone with your palm. You smack them. So your palm applies force. Now, there can be a positive or a negative charge that's moving, that's your current. So your palm is for positive charges, and the back of your hand is for negative charges. And by that, what I mean is wherever your palm is pointing is going to be the direction of the magnetic force on a positive charge. And wherever the back of your hand is pointing is going to be the direction of force on a negative charge. Now here's how we use all this. So the key when doing these problems is to hold your hand like this the entire time. Don't bend your fingers, don't bend your thumb. If you're dealing with just a regular old right hand rule problem, don't bend your fingers. If you do, you're going to get it wrong. So here's an example. You'll see something like this. So you guys have learned earlier in the unit that B is the symbol for the magnetic field. So B means magnetic field. And it's telling you that all these dots represent the magnetic field. I, hopefully you remember, is current. So this is your current flowing through the wire. Sometimes you'll see problems represent this with a V, telling you that that's the velocity of the charges moving. It's the same thing. It can be V, it can be I, it could be Q. I'm not sure exactly what all this program is going to use. We use all three interchangeably in class though, so you could easily see any of these three. So V, I, and Q. I see on one of the problems on your work, it says a V. So expect at least to see V, it just means current. So there's the current, here's the magnetic field, and the problem would ask you something like, what is going to be the direction of the magnetic force? Here's where your right hand comes into play. So remember, current is your thumb. So your goal is going to be to align your current with your thumb. So your thumb needs to point the same way that the current is right here. So I know my thumb needs to point that way, right? So my thumb has to point in the same direction as the current. Well, I also need my fingers. They represent the magnetic field. They need to point in the same direction as the magnetic field. Well, dots mean, and hopefully this comes up at some point in the lesson, dots mean out of the page. What that means is the dots are literally coming out to you. So my thumb needs to point there, while at the same time, my fingers need to be pointing out of this whiteboard. So I have to do something like this. Notice my fingers are pointing away from the whiteboard and my thumb is still pointing in the same direction as that arrow. Well, I've contorted my hand a little bit, but I haven't broken it, which is good. As long as you don't break anything, you're fine. Notice where my palm is pointing. My palm is facing down. So what we would say is the magnetic force that this current is going to experience is down. So you could say force is down to the bottom of the page, something like that. So this would be a basic example of how you apply the right-hand rule in a situation like this. Another example. I believe you guys also have a problem like this pop up. So you have a bunch of arrows like this, and they are labeled B. B is telling you it's the magnetic field. So the magnetic field is pointing down. And then you have this. This dot right here is telling you that this charge is coming out of the page at you. Remember, the dot means out of the page. Or in this case, my whiteboard, so it's coming out straight to you. Think of it like the head of an arrow coming right at you. So this is coming out of the page, my current, and the magnetic field is pointing down. Well, the part of my right hand that represents current is the thumb. So my thumb needs to point out of this page here. But my fingers need to be pointing downwards. So now I'm at yet another situation where I kind of have to turn myself around. So my thumb now points out of this page and my fingers point down. My palm is facing to the right. So that would mean the magnetic force is going to the right. So this current right here is going to experience a force pointing to the right. And this is how you use the right-hand rule. And notice that I kept talking about the palm. I was using examples with positive charges. Remember, palm, positive. The back of your hand would be negative. So if we did the same exact example with a negative charge, everything stays the same. The current is still coming out of the page. So my thumb still points away. And my fingers still have to point down. But if it's a negative charge, now you follow where the back of your hand is pointing. And the back of my hand points to the left instead. So I apologize if any of this was hard to follow. I'll make another video with different examples if that helps more. Hopefully you were able to see the whiteboard for most of it. And if there are more questions, please ask and I'll make as many videos as I need to. Bye.